Welcome to this session. This session will evaluate determinant of three variables, y1, y2, and y3. And we have already been given the answer to be 4. So our task is to manipulate the Jacobian and to see that we are ending up with the answer as 4. So solution. So solution, by definition, the Jacobian of y1, y2, y3 with respect to x1, x2, x3 is given by partial y1, y2, y3 is given by over partial x1, x2, x3 is the determinant partial y1, partial x1, partial y1, partial x2, partial y1, partial x3, partial y2, partial x1, partial y2, partial x2, partial y2, partial x3, partial y3, partial x1, partial y3, partial x2, partial y3, partial x3. That's by definition. So our task would be to find these partial derivatives and get the answer. So given that y1 is x2, x3 over x1, then it should be easy to see that partial y1, partial x1. Now you evaluate it easily by writing y1 equals to x2, x3, x1 raised to power -1. So use power rule, drop -1, so we'll have a negative sign, x2, x3, and subtract 1, you'll get power -2, which is the same as over x1 squared. And then partial y1, partial x2 should be easy to calculate. This be x3 of x1, and partial y1, partial x3 should be easy to calculate, x2 over x1, y2 given by x3, x1 over x2 means partial y2, partial x1. By power rule, we get x3 over x2, partial y2, partial x2 will be easily calculated by rewriting this one as x3, x1, x2 raised to power -1. Then use power rule. So drop will have a negative, x3, x1. Now subtract 1 from here, we get 2. So it's like divided by x2 squared, partial y2, partial x3. This will be x1 over x2. And then next one, we are given that y3 is y3 is x1, x2 over x3. So that means partial y3 partial x1 will give you x2 over x3 from this. Partial y3 partial x2 will be x1 over x3, and partial y3 partial x3, you rewrite this one as x1, x2, x3 power negative 1. So drop, we have negative x1, x2. Then this will subtract 1 power negative 2. So bring it in the denominator, we have square. So replacing those values in the formula, we get minus x2, x3 over x1 squared, and then x3 over x1, and then x2 over x1, and then we have x3 over x2 minus x3 x1 over x2 squared, x1 over x2, x2 over x3, x1 over x3, negative x1, x2 over x3 squared. Just replacing the values we have found out in this process into the definition of the Jacobian. So here, if you don't know how to manipulate determinants, you'll get stuck. But this is how we are going to solve this. Know that if you have a determinant, A1, B1, C1, A2, B2, C2, A3, B3, C3. If you have another determinant, delta prime, in such a case that I have a constant multiplying the first, say first row, then A2, B2, C2, A3, B3, C3, then it can be proved that the determinant of this new, the value of the new determinant delta prime is the same as factoring out this k in the first row, multiplying by A1, B1, C1, A2, B2, C2, A3, B3, C3. And it's in general that if we have a factor for any given row or any given column in a determinant, then the value of the determinant is the same as factoring out that determinant and then multiplying by the resulting determinant after factorization. So the first thing we do is that we are going to multiply each of these rows by 1. By this 1, we write it in a special way so that it can help us to simplify the terms across the rows. So I'm going to say that row 1, I'm going to have x, because the denominator highest power is 2 of x1. So I'll say row 1, I have x1 squared over x1 squared, row 1. And then row 2, I have x2. So I say x2 squared over x2 squared, row 2. And then this one, I say row 3, I multiply by 1, but that one I write it as x3 squared over x3 squared, row 3. Now, you see, when you multiply a number by 1, we are not changing the value of the number. But because we have written our ones in special way, they are going to help us to reduce this determinant to some form that can help us simplify that expression. Now you see, if I say I'm multiplying by a number by a over a, it's the same thing as saying I have a times 1 over a. It's the same thing, and it's still 1. So because this one is being multiplied, so I just write the next step will be, now all these such fractions, I write them outside here. So 1 over x1 squared, x2 squared, x3 squared, and then determinant of. So I now take the a which represents x1 squared, x2 squared, and x3 squared. I multiply by the respective rows. So this row by x1 squared, I'll get negative x2, x3. This I'll get x1, x3. This I'll get x1, x2, because one of the x1 squared is cancelled out by the denominator. And in the second row, I'll have x2, x3 minus x3, x1 or x1, x3. And then this will give me x, remember I'm multiplying this one by x2. So it'll be x1, x2. Here, this is multiplied by x3. So I'll have x2, x3, this one, x1, x3, this one, negative x1, x2. There is no sin I've committed because what I did was to multiply each row by 1. But I wrote my ones in a special way so that they can help me to reduce the determinant. And if you check this new determinant here, you see this first row, all the elements have a factor x2, x3. So I pull out and I have x2, x3 divided by x1 squared, x2 squared, x3 squared. So this will be minus 1, this will be 1, this will be 1. I keep this other the way they are, x1, x3 minus x1, x3. Remember x3, x1, the same as x1, x3. And then x1, x3, x1, x2, x1, x2 minus x1, x2. Next step, you see this second column has, every element has a factor x1, x3. So I pull it out of the determinant. And so I'll have x1, x3 times this x3 will be now x3 squared. And then denominator is still x1 squared, x2 squared, x3 squared. Determinant of minus 1, 1, 1. So this will be 1 minus 1, 1. This is x1, x2, x1, x2 minus x1, x2. Good. Now also, this third column, every element has a factor x1, x2. So I pull it out of the determinant. So x1 will multiply here, I get x1 squared. x2 will multiply this x2, I get x2 squared. x3 is x3 squared divided by x1 squared squared x3 squared. Then determinant of negative 1, 1, 1, 1 minus 1, 1. Now this will be 1, 1 minus 1. There's no sin we have committed. And now at this point, you see, we now are at liberty of saying x1 squared, x1 squared, x2 squared, x2 squared, x3 squared, x3 squared. So this is just determinant of negative 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1. So you see the properties of determinants have helped us now to do away with all the variables x1, x2, x3 that were in the determinant. Now, so our Jacobian is now just a 3 by 3 determinant involving only numbers. So which is determinant of negative 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1. Now let's play with rows now. So we say let row 1 to remain row 1, row 2 to be now row 2 plus row 1, and row 3 to be row 3 plus row 1. Remember, if you add a multiple of a row to another row in a determinant, the value doesn't change. So this means that the Jacobian will be given by determinant of, so this negative 1, 1, 1, 1 plus minus 1 is 0, 1 minus 1 plus 1 is 0, 1 plus 1 is 2, 1 plus minus 1 is 0, 1 plus 1 is 2, minus 1 plus 1 is 0. Now this is an easy determinant to evaluate using compact expansion. So the sign of this element is usually positive, negative, positive. So expanding along the first row, this determinant will be negative 1 times the submatrix 0, 2, 2, 0. And this will be negative 1 into 0 times 0 is 0, 2 times 2 is minus 4, and negative 1 times minus 4 is what gives us 4. That is the answer that was given. Thank you.